Alright, so here we go with a slightly more complex example. Once again, what we're doing is we have an argument and we're trying to demonstrate that it's valid or show that it's valid. So these assumptions are the premises of our argument, and down here this conclusion that we're working towards is the conclusion of the argument itself. Okay? So let's take a look at this argument and kind of say it in English and see if a strategy pops out, to us that we can follow in order to get to this conclusion. So this says F is equivalent to not G, so you can't have one without the other. You can't have F without not G, which is another way of saying that if F is true, G has to be false. If you have if D, then not G, and not H and D, okay? Now, let's say that looking at that, we didn't really know how to solve it, like we don't see what to do. A way to proceed in a derivation is to do what I call unpacking the premises. Take what you have and start applying every elimination rule that you can and get everything separate, break the sentences that you have down as far as possible, and then see where you can go from there. And that kind of mirrors natural reasoning, right? Once again, this is a natural derivation system. It's supposed to kind of mirror how you reason. If you have some argument and you don't really know what to do with it, a good thing to do is to start really scrutinizing the premises and seeing what you can do with them. So let's go ahead and apply that strategy here. So we can't do anything with this. We would have to have F or not G. Likewise, we can't do anything with this. We have to have D first. But this third line, we can apply conjunction and elimination to it. In fact, we can do it twice. Okay, so now we have not H and D, and let's see where we can go from there. Well, actually, having not H, that's half of what we're trying to get, right? So now we just need to get F, and then we can use conjunction introduction to put those two things back together, and we'll have the goal or the conclusion that we're working towards. All right, so what can we do now? Well, it looks like because we have D now, we have the antecedent to this conditional, we can go ahead and use conditional elimination on line 2. So I'm able to do this just because I know these rules. I've been doing this for a while. If you find that you don't have them memorized yet, which is perfectly natural, a good thing to do would just be to have the textbook open and go through the list of the rules and think, what can I use in this situation? Can I use this one? Can I use that one? And so forth. So now what can we do? Well, we already have not H, so what we're trying to get is F. And look, we have not G. If not G is true, then F must also be true, right? Because we have this material biconditional here. So we can use the material biconditional elimination rule with not G to get F. And again, we have to say where each line came from, right? How we're getting each line of this proof. And here, we used the material biconditional elimination rule, and we used lines 1 and line 6 to do that, okay? So now we can go ahead and finish up this derivation. We can get this by, now we're going to use an introduction rule. We're going to use conjunction introduction on lines 4 and 7. And that completes our proof.